Dear students, in this part we have to discuss and derive Lensmaker's formula. So before deriving Lensmaker formula, first we have to observe this figure. So let us consider a convex lens. So it consists of two spherical refracting surface xp1y and xp2y. And here O represents a point object, C1 and C2 represents radii center of curvatures, and R1 and R2 represents radii of curvatures. That is, R1 represents distance of C1 from optical center O dias, R2 represents distance of C2 from optical center O dias, and U represents distance of the object from the optical center. And here C1 N1 represents normal line at point A, and C2 N2 represents another normal line at point capital B. So that is denoted by point B. So here OA represents a ray of light emerging from the point object O and incident on first spherical refracting surface xp1y. And here mu1 represents absolute refractive index of the real medium, and mu2 represents absolute refractive index of the lens, that is convex lens, and this should be denser medium. So the lens is kept in a real medium and the point object is placed on the principal axis in the real medium. So light is traveling from real medium to denser medium, and hence after refraction the refracted light ray AB bends towards the normal C1N1, and this refracted light ray meets the principal axis at ideas if there is no second spherical refracting surface xp2y. So ideas represents position of the image formed by first spherical refracting surface xp1y for the point object O. Aduna apina Lensmaker formula je derive to ge haradi sigi figure je hana aduna khangba darkar oi. Aduna sigi Lensmaker formula derive to the step ani sangani. Amana refraction through spherical refracting surface xp1y. Second step now, refraction through spherical refracting surface xp2y. On the on but the xp1y case na lakan the objects the later object the lakpa light ray ama xp2y the yire aduga karigumba si xp2y je leram draba second spherical refracting surface of leram dradi sigi refracted light ray abj sumna sakrani aduga principal axis ka ideas da meet tawrani punarani aduna ideas na sigi u haiba point object sigi image oiduneba kanana form tawba si ahan ba xp1 y haiba first spherical surface na form tawba image oiduni aduna sidaleba b dias na distance of ideas from the optical center, and these ideas represents virtual image formed by xp1y. Aruga second case ta laktu jina mu let us consider second spherical surface xp2y. xp2y gi object ti kana oi lo de gai tar di sigi ideas no object oi lo da ba xp1y gi image na xp2y gi object oi lo da ba aduna sigi ideas harise karba medium da lagi haire da koina denser medium mu2 da layena logani sigi mu2 haiba denser medium da layuni sigi idea se aduna xp2y case di object se ideas in the lorani aduna amuk sagi sida laiba AB haiba light rays appears to come out from ideas dagi lai na koina consider to ba yai aduna sigi x p2y sida mu sigi AB haiba light rays na jaira kanda sumna satin huta koina sigi normal C to N2 dagi phaidorani maramde karino haitari light se denser medium to rarer medium da lapuneba glass dagi here da aduna sigi light ray AB je sumna satin huta tasembagi di sigi xp2y to mujaira kanda normal C to N dagi phaidorani aduga principal axis ka I da unarani di tawrani aduna sigi as represents position of the image formed by xp2y for the partial object ideas, and B represents distance of capital I, that is finite image, from the optical center or dias. So, Lensmaker formula may be defined like this. It is the relation between refractive index mu, focal length f, and radii of curvatures, that is r1 and r2 of a lens. It can be expressed as 1 by f equal to mu minus 1, 1 by r1 minus 1 by r2, where mu equal to relative refractive index of lens, that is 2 with respect to the medium in which the lens is kept, that is 1, mu to 1 high z. And this, it can also be expressed as absolute refractive index of lens, that is mu 2 divided by absolute refractive index of rarer medium, that is mu1. So this mu or mu21 may be read as relative refractive index of lens, that is mu2 duni, with respect to the medium in which the lens is kept, that is rarer medium mu1. Now when Lensmaker formula hairagadi sidale riba formula jini 1 by f equal to mu minus 1 into 1 by r1 minus 1 by r2. See, we derive with the help of this ray diagram. So let us see how to derive Lensmaker formula. Let us consider a convex lens bound by two spherical refracting surfaces xp1y and xp2y having radii of curvatures r1 and r2 respectively. The lens is made of a material of absolute refractive index mu2, which is kept in a rarer medium of absolute refractive index mu1. Let a point object O is placed on the principal axis in the rarer medium mu1 at a distance u from the optical center. A ray of light OA emerging from the object is incident on xp2y, that is first spherical refracting surface. Since light is traveling from rarer medium to denser medium, the refracted light ray AB bends towards the normal C1 N1 and meets the principal axis at I dias at a distance B dias from optical center O dias if there will be no xp2y, that is second spherical refracting surface. Aduna sida harise sana sa explain ta biduni sida point object laire principal axis ta adu si object se rarer medium absolute refractive index mu1 da laiduni o dagi lakpa light rays OA laire adu si light rays na lens form matung da normal C1 N1 of the faisal ani adu karigumba siki second spherical refracting surface xp2y je leram dradi a b je sumna laaga principal axis ka I dias ta kaunarani aduga b dias na distance of I dias from the optical center O dias oiduini. Hence I dias represents the partial image in the denser medium of the point object O formed by spherical refracting surface xp1y. In case of refraction through xp1y, we may write mu2 divided by b dias minus mu1 divided by u equal to mu2 minus mu1 divided by r1 and write it equation number 1. Aduna sida lai je wo I dias na idea sina x p1y haiba sigi first spherical refracting surface sina same form to image oidoini kanagi sigi point object kaida leiba in the rear medium aduna refraction through x p1y je kari ga manage bu object na rear medium da leiba adu ga magi image na denser medium da leiba mane aduna koina mamagi part ko mamagi previous part koina derive to formula ani ka ingjan ga dawni adi karino refraction through spherical refracting surface when object lies in rear medium ki case da by radiation formula ma derive to gis de leije mu2 by v mu2 by image distance minus mu1 by u object distance equal to mu2 minus mu1 divided by r sigi formula je akoina refraction through x p1y da apply to je sigi formula je sijina dini ko sigi case da aduna in case of refraction through x p1y object distance ti u laide image distance ti v dias ogadaba distance of ideas from odias aduna sigi formula je yarba v je v ibe yaroi it should be replaced by v dias sigi v gi mota v dias hairani adu sidala ibe u je object distance is samanare adum u dum oirani adu sidala ibe capital R je radius of curvature of x p1y x p1y ki radius of curvature di capital R1 ni aduna sigi capital R je again replaced by R1 so we may write like this mu2 by v dias minus mu1 by u equal to mu2 minus mu1 divided by r1 sina xp1y da refraction light na form set pagi formula sida leire in fact there is second spherical refracting surface xp2y now ideas will be the object for xp2y. The refracted light ray AB again suffers refraction through xp2y since light is traveling from denser medium to rarer medium. The refracted light ray bends away from the normal C2N2 and meets the principal axis at I having distance v from odias as shown in figure. Now the figure is there. अखोइन से लाखुइसिना xp2y जे ngasa अखोइन लैरमद्रगदि ab जे सुमना चलगा ideas ta unani हाइबनि अदु तसेंबगिति xp2y जे लैयेबा अदुना सिदा लाइबा ab जे xp2y द मुग यई रकांदा रिफ्रैक्शन अमुक थोक्तोइबा अदुना xp2y की ऑब्जेक्ट अखोइन ओ लवररोय मागी ऑब्जेक्ट अखोइन ideas से ओइना अखोइन वाखनदा एज्यूम तौनी लक्सलनि अदुना सिगी ab हाइबा रिफ्रैक्टेड लाइट रे जे सिगी ideas हाइबा ऑब्जेक्ट in the denser medium दगी थोड़ा पनी ना फिर ना लॉक्सन लने अब अदुना सिगी लाइट ए बिजना सिगी xp2y दे ये वो मतलब द लाइट से denser medium glass दगी rarer medium it may be ear or be आई glass दगी rarer medium द थोड़ा का दुनिया अदुना सिगी refracted light ray से normal C2N2 दगी फाइटोरा अनी अदुगा capital I द principal axis का उनरानी अदुगा सिगी v जना distance of I from odias. Hence, I, capital I, represents the position of real image of the virtual object ideas formed by xp2y. In case of refraction through xp2y, we may write mu2 divided by v dias minus mu1 divided by v equal to mu2 minus mu1 divided by r2 and write equation number 2. Now, the figure is the capital I is na real image की position ओइदनी अदुगा object ना ideas की कनाना form तोबा xp2y अदुगा सिगी case इता idea refraction through xp2y दा refraction थोपजे करम बक case का माने गेबु object ना denser medium दा लइबा that is ideas को अदुगा image na rarer medium da leire I aduna in case of refraction of light through spherical refracting surface when object lies in denser medium we may write this formula that is mu2 divided by object distance minus mu1 by image distance equal to mu2 minus mu1 divided by r sigi formula ja pen mama derive tawrabani adu sigi case da u have the object distance ni aduna in case of xp2y da object distance higher the b dias in lowdaba distance of I dias from optical center aduna sida yauri ba u gi mota b dias na mau silani aduga b id image distance samanare distance of image from the optical center b samanare adu sigi r je radius of curvature for xp to y gadaba aduna sigi r gi mota xp to y gi radius of curvature di r2 capital R2 neba aduna sigi formula je sizinarkanda akoina refraction through xp to y the refraction through case akoina si formula siba sigi formula je sumaina iba ya equation number 2 je sigi formula ji lapani sila is next subtracting equation 2 from equation 1 we have equation 2 do equation 1 dagi minus toroji subtract toroji auna koina mamang de iba equation 1 ga 2 go do subtract on zero aduna equation 2 do 1 dagi khaidu go do ni na equation 1 hana iraji left side ta leiba term ani do minus taroni right side ta leiba term ni do minus taroji aduna equation 1 das mai leibani mu 2 divided by b dias minus mu 1 by u equation number 2 gi left side na mu 2 by b dias minus mu 1 by v ani je minus toroba aduka right side ta equation 1 da lerido mu 2 minus mu 1 by r1 right side ta equation number 2 da lerido mu 2 minus mu 1 by r2 adu ani je minus toro then sigi first bracket open toro di sigi mu 2 divided by b dias minus la ani sigi minus ka sigi plus cancel sakrani ani je cancel sakrani adu le hodu je minus mu 1 by u silaire sigi minus minus plus mu 1 by v plus mu 1 by v silaire ko sigi ani je cancel sakrabani next right side ta bulaji right side ta je mu 2 minus mu 1 samani sida common oire adu si common oin lokthokro mu 2 minus mu 1 adu first time le hodu je 1 by r1 later second term no 1 by r2 aduna mu 2 minus mu 1 is common with rd 1 by r1 minus 1 by r2 is my ebr next step to sigi dividing both sides by mu 1 nakan animak ta mu 1 aduna divide tok tho aduna sigi mu 1 by u1 je mu 1 divide already mu 1 cancel sakre 1 by u later ni similarly mu 1 by b je 1 by v later mu 2 by mu 1 minus mu 1 by mu 1 di 1 tare cancel sakre aduna akoi gi sigi left side right side the mu 1 already divide to kanda we may write like this minus 1 by u plus 1 by v equal to mu 2 by mu 1 minus 1 by r1 minus 1 by r2 next akoi laktu je logic equation sigi makhala laktu je when the object O is placed at infinity, that is u equal to infinity. Object distance u do infinity oiraba. I object yam lamna lairagadi haibani. Then the finite image will be formed at principal focus, that is image distance v equal to small f, that is focal length of the lens. I the point object se yam lamna lairaba lens tagi yam lamna thamtari object se infinity de later the image se kai de lagebu magi focus la laganeba principal focus ta aduna image distance b je focal length ka manner neba image to focus la ready distance of image from the optical center je focal length hairani aduna si the small f na focal length of the lens in the lower ni aduna nga sa mamang the direct formula do say minus 1 by u plus 1 by v equal to mu 2 by mu 1 minus 1 by r1 minus 1 by r2 the sinjala zeba hai u gi mota infinity ro v gi mota f ira zeba adi smile ani then mu 2 by mu 1 ze we mirror like this mu 2 1 relative refractive index of lens that is medium 2 with respect to rear medium that is 1 smile ebi 1 by infinity di 0 ga mane aduna 1 by infinity 0 sakre 1 by f laire again mu 2 1 ze generally it may be represented by simply mu. See the mu here is a mu to 1 we doing and mu minus 1 later, see later, and write equation number 3. And this equation 3 represents Lensmaker formula, and we may write like this where mu equal to mu to 1. That is absolute refractive index of lens or glass divided by absolute refractive index of the other medium. That is relative refractive index of glass, that is lens, with respect to the rear medium. in which the lens is kept.